Nektar++ is an open-source spectral HP element framework for the development of high-fidelity solvers for partial differential equations and simulations in fluid dynamics, aeronautics, heat transfer, biomedicine, renewable energy, and much more. Nektar++ delivers an efficient and flexible platform for high-order finite elements with high scalability. Users use Nektar++ to develop their own solvers or conduct simulations using fully fledged solvers already provided. Why Nektar++? Designing cutting-edge technologies such as automotive and racing cars, aeroplanes, and wind turbines requires high-accuracy information regarding turbulent flow. While many existing packages are suitable for common engineering and scientific applications, they cannot provide the detail required for cutting-edge technologies. Nektar++ is advanced, robust, and reliable software for achieving accurate simulations and detailed information required by state-of-the-art technologies. So what is the spectral HP element method? It is a class of high-order finite element methods using elements of size h to tessellate a computational geometry while approximating the variables in each element with a combination of polynomials of order p. The technique offers the flexibility of low-order methods in discretizing a complex geometry alongside high accuracy and the exponential convergence of high-order methods. Why do we need such high-accuracy simulations? Even with state-of-the-art supercomputers, we cannot resolve the smallest scales of turbulence. Using Nektar++ and its high-accuracy method provides extra information from the flow. Nektar++ includes a native CAD reader and geometry-conforming mesh tool called NekMesh. It supports various element types, including triangular and quadrilateral in 2D and prismatic, tetrahedral, pyramidal, and hexahedral elements in 3D and their combination. It also supports high-order curved elements for curved geometries. Nektar++ comes with fully fledged solvers, including a compressible flow solver for viscous and inviscid flows and an incompressible Navier-Stokes solver. The turbulence modeling is addressed with implicit large eddy simulation and direct numerical simulation. Simulating flow instabilities is another strength of Nektar++. Nektar++ has also been used for biomedical applications and has dedicated solvers for cardiac electrophysiology and pulse wave propagation. Cutting-edge applications include plasma fusion modeling, fluid structure interaction of slender structures, and shallow water simulation. Nektar++ has been utilized on supercomputing facilities within the UK and internationally. The Nektar++ project was launched at Imperial College London and University of Utah in 2005. It has been used by academic research groups and industrial R&D labs, and it is one of the flagship solvers of UK Turbulence Consortium. The Nektar++ documentation includes a user guide, tutorials, and a repository, which are all freely accessible with cross-platform support from Linux and Mac.